Imagine you need to deploy a passive acoustic monitoring system across a network of distributed sensors, classifying vessel traffic in real time and adapting as new acoustic signatures appear. Today, that involves stitching together raw audio pipelines, custom machine learning training, separately deployed inference services, an analyst console, and a retraining loop, usually built by different teams on different stacks with no shared audit trail. In this demo, we'll show how Domino accelerates that system. The same approach works for radar signal triage, ISR feed classification, or any sensor fusion pipeline that needs analyst adjudication and continuous retraining. Here's the result. TIDES, or Tactical Intelligence from Distributed Edge Sensors, is a closed-loop underwater acoustic classification platform. It's a live operations dashboard, a 3D globe of distributed sensors with detection streaming in. Each marker is color-coded green, amber, or red based on what's being heard underwater. Behind the scenes, every audio clip flows through an anomaly detection model that's been trained on the ambient noise at the sensor. When an anomaly is detected, the sensor goes red, flagging for analyst review. The analyst opens the detail panel and reviews the derived spectrogram. A spectrogram image classifier runs to automatically identify the vessel type based on its distinct acoustic signature. The model also highlights parts of the image that helped it reach that decision, helping the analyst key in on distinct image features. Additionally, an agent runs to explain its decision in natural language. If a detection is flagged as amber, that indicates an anomaly was detected, but the classifier couldn't reach a clear decision. The system collects these signatures from across the sensor network and presents them to the analyst, facilitating continuous model improvement to detect unknown signatures. The analyst can chat with an operations assistant that can summarize collections, call internal tools to cluster the unknowns across sensors, propose a new vessel class, and trigger a retraining flow, all from the same pane of glass. The system uses multiple machine learning and agentic capabilities, but every agent decision is traced, and every model version is logged and linked back to its training data, code revision, and approval record. Here's how it was built. Domino is set up to adapt to how your analytics teams already work. The team connected Domino to their external sensor audio archives through a single governed entry point on a high throughput volume, and every session that touched acoustic data was automatically logged, no matter where the data lived. Developers worked in their editor of choice with compute environments IT had sandboxed and automatically versioned for reproducibility months later. They scaled to GPU machines across cloud and on-premises infrastructure for spectrogram generation and model training, and attached whichever distributed compute framework fit each workload, whether Spark, Ray, Dask, MPI, or Slurm. They pulled in governed LLM connections through the Domino AI gateway for the operations assistant, with detailed auditing on every API call. The experiment manager captured every training run: hardware, packages, hyperparameters, classification accuracy, and the model artifacts themselves. Before any code was written, the project lead attached a governance bundle custom-made with agency-specific stages. Developers saw exactly what evidence was needed at each phase. When ready for review, the compliance officer can add findings with priority and deadlines directly in the bundle. No email threads, no spreadsheets. The model registry promoted the winning models with auto-populated cards pulling in parameters, metrics, and the held-out evaluation set, feeding directly into the governance bundle. Clicking on Experiment Run takes you back to the exact experiment that produced the model. Once approved, the team published the system as a single Domino app that serves the operations dashboard. No DevOps tickets or containerization expertise required. Domino traces agentic decisions behind the scenes, capturing every tool call, token usage, and intermediate reasoning step, ensuring that every adjudication is auditable. When a program manager asks why a new vessel class was added to the classifier, you can point to this trace and the black box is removed. When updates are needed, such as when a new acoustic signature appears that the current model can't classify, the operations assistant triggers a Domino flow that retrains the classifier with the new class and registers the next version in the model registry. The same hardware and environment used originally is spun back up in minutes, and the closed loop runs end to end. The record of what was run is preserved in Domino for reproducibility and traceability in the future. The control center shows all deployed assets, compute costs by project, and the complete audit logs of who accessed data and when. This came together because Domino provides three things mission-critical AI requires: a system of record that captures everything automatically, a production-ready workbench that adapts to how your analysts and contractors already work, and data and infrastructure orchestration across networks and environments. Program managers, CDAOs, and compliance officers get centralized control and audit trails. Analysts and contractors get fast access to the tools and compute infrastructure they need. Visit domino.ai/public sector to set up a demo for your requirements.